In this lesson, we're going to talk about angles. Now, angles are a way of measuring direction, and we've all had experience talking about direction in the sense of I'm heading west or I'm heading to the northeast. But if we want to be more specific about our direction, we really need a more refined tool than that. So that's what we're going to be talking about today. So angles can be measured in a couple of ways. In this video, we're going to focus on measuring angles in degrees. And we'll talk about another way of doing it in a future video. But first, let's start with the definition. So the measure of an angle is a measurement between two intersecting lines, line segments, or rays, starting at the initial side and ending at the terminal side. So the way to understand this business of initial side and terminal side, I think, is to kind of think of the terminal side like it's the door. And so what you're going to do is you're going to open the door from the initial side to the terminal side. Now, the symbol theta is one that we are going to commonly use whenever we're talking about angles, as you see in the picture here. Theta is a Greek letter. But there's other symbols we use as well. Phi, and actually both of these are phi. This is kind of like the cursive version of phi, I guess. Alpha, beta, and gamma. Those are all symbols that you'll see throughout this course. And of course, we'll use some of your typical favorite algebra letters, X, Y, Z, and so on. So, but I wanted to point out some of the symbols that maybe you've had a little less experience with. All right, so when we measure angles in degrees, we're going to base it off this idea that one full rotation is equal to 360 degrees, and you've probably had experience with that already. And so that, of course, would mean that one single degree is exactly 1/360th of a circle. Okay. And the last thing that we need in terms of just being on the same page with one another is to agree on how it is that we're going to measure angles. Okay. So let's suppose that I want you to draw me the angle 45 degrees. Okay. Well, there's a lot of different options, and I'm just going to draw two of the options. One would be to say, well, I could maybe call this 45 degrees if this is the angle we're talking about. But if I could also, I suppose, say that this is 45 degrees if this is the angle we're talking about. So you see, we need a place to kind of start from, and we also need a direction to rotate in order to make any sense of what sketching 45 degrees means. So unless otherwise directed to, you're always going to draw angles from standard position. So standard position is starting at the positive horizontal axis, so the positive x-axis here, and going counterclockwise. So what that means is that this here is the proper 45 degree angle that I asked for. Now this one down here has some meaning as well. We would actually say that this is negative 45 degrees because it's starting from that same spot, but you're going in the clockwise direction instead. So what I want to do on this slide is to have us go through and mark some of the important angles that we're going to encounter throughout this course. So I want to focus on the black lines that you see here, these four black lines that I've drawn in this circle. So first of all, let's notice that the black divides the circle. Oops. Circle into fourths, right? So with that observation and knowing that there are 360 degrees in a circle, it might make sense to just start by taking 360 degrees divided by 4. That, of course, gets me 90 degrees. So what that means is as I go from one black line to the next, I've gone through 90 degrees. So again, understanding that standard position, angles measured from standard position, go from the positive x-axis counterclockwise. Let's call this 0 degrees. So that would have to mean that this first one is 90 degrees. And then if I add another 90 to that, that makes that 180 degrees, and add another 90, we're at 270 degrees, and then add another 90, we're at 360 degrees, and also back to where we started, and this agrees with our idea that one full rotation is 360 degrees. Okay. Let's go next to the blue color that we see there. Now if I take the blue along with the black, okay, so I'm going to say blue and black, well, that divides a circle into eighths, doesn't it? Oops, into eighths. So with that idea, let's take our 360 degrees and divide it by 8. And when I do that, I get 45 degrees. So what that means is that every time I hit a blue or a black, I've gone 45 degrees. So that means I can fill in 45 degrees here. 45 plus 45 is 90. 90 plus 45 is 135. 135 plus is 180. 180 plus 45 is 225. Add another 45, we're down at 270. Add another 45, and we are at 315 degrees. Okay. So the only one we have left now is what we've got in red. So again, let's put the red together along with the black. So red and black. Divide the circle into 12ths. Okay, so let's take 360 degrees divided by 12, and that's going to give me 30 degrees. So every time I hit a red, that's 30 degrees. So 0 plus 30. 30 plus 30 is 60. 60 plus 30 is, of course, 90. 90 plus 30 is 120. And we can go through in the same fashion and just fill all of these in. So what you're seeing here is basically what I want you to have memorized as soon as possible. It's going to be really important for you to be able to identify where these special angles are on the circle and be able to work with them rather extensively. So make that your very first order of business, is just getting this image that's in front of you memorized. So once we memorize the special angles on the circle that are between 0 and 360, it makes sense to then ask about angles that may not be between 0 degrees and 360 degrees. So in an earlier slide, we even already kind of broached the subject when we talked about a negative angle. So first of all, let's just remember that a negative angle is going to be when we measure clockwise from standard position instead of counterclockwise. Okay. And then the other definition that we need here is that of coterminal angles. So coterminal angles are ones that terminate in the exact same place on the circle, even though they're different values. Okay. So in example 2 here, it asks us to mark the location of negative 60 degrees, 495 degrees, and 1,590 degrees on the circle below. And in each case, state the coterminal angle. And I can see that I left something pretty important out here, so go ahead and just add this into your notes. State the coterminal angle that is between 0 degrees and 360 degrees. All right, because there's many coterminal angles within a given angle, so we want the one specifically between 0 and 360. All right, so let's start off with negative 60 degrees. Now, first of all, if I understand that a negative angle is just simply measuring the angle clockwise from standard position, what I could do is just go over to this picture here and just make a note that, okay, there's 60 degrees. So negative 60 degrees must just be simply going that same angle, but in the clockwise direction. So I could just mark over here that, okay, this must be the location of negative 60 degrees. Okay, so that takes care of the first part, but it did also ask me for the coterminal angle that's between 0 and 360. Now I can see over here that that would just be 300 degrees, right? But let's talk more generally about how I get that. So I know that if I've got an angle here, if I add 360 degrees to that angle, since 360 degrees is one full rotation, that should take me exactly back to where I started. So if I start at negative 60, I add 360, 300 degrees should be in the exact same place. So 300 degrees is coterminal with negative 60 degrees. All right, let's look at 495 degrees. Okay. Well, in the previous problem, I was able to add 360 degrees and end up in the same place. So, of course, I should be able to go in the clockwise direction 360 degrees and also end up in the same place. So I understand that if I take 360 degrees away from 495 degrees, that the result should be coterminal. Okay, so I have what, 135 degrees is coterminal with 495 degrees. But then if I've got it memorized that 135 is over here on the circle, then I know that 495 degrees should show up right over there. All right, let's take this last one here, 1,590 degrees. So taking this idea from the previous two, I know I can add 360 degrees or subtract 360 degrees and end up in the same place on the circle. But in this case, I have a feeling that if I subtract 360 from 1,590, I'm not going to quite get something that's between 0 and 360. But if I can subtract one value of 360 and end up on the same place, if I subtracted 2, I should still end up on the same place on the circle, and 3 and 4 and so on. So for this one, the question is more, if I take 1,590, how many times would 360 degrees go into it? Okay. So I'm just doing a little long division here. I believe if I sent 360 degrees into 1,594 times, then that would work. So understand what I've done here. I've taken 4 times 360. I am now subtracting that from my angle, and I'm seeing what I'm left with. So I've got 0 there, 5 there, and 1 there. So in other words, if I take 1,590 and I subtract 4 copies of 360, put my degree symbols there, then I'm left with 150 degrees. So I know 150 degrees is right there, so that tells me that 1,590 degrees is right there on the circle, and that 150 degrees is my coterminal angle that happens to be between 0 degrees and 360 degrees.